Alright, hope everyone's doing well today. I'm going to cover section 2.15, so that'll be the first section that we'll cover for this coming week. So we're going to talk about the Pythagorean Theorem today, and just to start out as an example, we're going to look at each of these rectangles, so we have 4 of them total here, and we're going to draw the diagonal in on each of them, and then we're going to kind of guess what the length is, or what the length could be of those diagonals, okay? So let's look at this first one here. So this first one, if I draw a diagonal, you can either do from the top left to the bottom right, or we could do the opposite way, right? But I'm just going to do it this way, since they'll be the same length. And now that I see it, it looks like this diagonal, it looks like we have a length of 5 here on the bottom. So we have what, 1, 2, 3, 4, 5 units, and then we have 3 units high as well. So if I have a 3 by 5 triangle and I'm looking at this, I think that this diagonal is going to be a little bit longer than this 5 down here, right? So if I take this and just kind of let it fall down, so just like it's right here, it just falls down. I'm going to kind of trace like a line, and it looks like if it kind of falls down, it's going to be a little bit longer than those 5 units. So I'm going to guess that this diagonal here is a little bit longer than 5 units. So I'm just going to guess that it's 6 units. So I'm going to label D for diagonal, and I'm going to say that's 6 units. Okay? And then I can use that exact same procedure to do all the other ones as well, right? So I'm going to draw in the diagonals for the other ones. Okay, and it doesn't have to be exact, it's just kind of an estimate here. So if I have this one, and it's going to do the same thing with, just like I did up here, so I'm just going to let it kind of fall down. If I do that, I think it's going to be right about there. So I think 1, 2, 3, 4, 5, 6. I'm going to say that this diagonal is about 7 units. Okay? And I could do that with all the other ones as well. Like this one, I could have it fall kind of like this and go that way. To fall down there. And then the same thing with this one. Maybe it'll fall down right about here, right? But the point is that we're kind of estimating the diagonals here, but we don't want to just estimate it. We want to know exactly what those diagonals are. And that'll kind of lead us into the Pythagorean Theorem. So the Pythagorean Theorem, what it's going to do is if we know the lengths of 2 sides, we can find the length of that diagonal, exactly what it is, instead of just kind of guessing like this. Okay? Alright, so let's look at the formula on the next page here. So the Pythagorean Theorem, it only works for a triangle that has a 90-degree angle, and that's also known as a right triangle. So just looking at this picture before I move on with the definition, we have this right angle down here, and you can tell that there's like a little box there, and that just means that it's a right angle, and that's also 90 degrees. They're the same thing. Okay? So it says in a right triangle, the sides that form the right angle are known as the legs. So these two, it's the ones that touch that right angle in the corner. Okay? And then the one that's the side that's across from the right angle is called the hypotenuse, and it's always the longest side of the triangle. Right? So if we look at it this corner, we go directly across, that's the hypotenuse. Okay? So right triangles have a special relationship between the lengths of their sides that's expressed in the Pythagorean Theorem. So basically what the Pythagorean Theorem is saying is that we square the length of this leg, and we square this leg as well. When we add those together, that's going to equal the square of the hypotenuse. Okay? So I'm not going to do anything to prove that, but I will post a video in the description that kind of gives you a more intuitive reason as to why this is true. So I'm going to post a video in the description for you. Okay? So if we wanted to look at this more abstractly, we can say that the Pythagorean Theorem, and you'll see this just about everywhere, is a squared plus b squared equals c squared. And a and b are just the legs of your hypotenuse, right? So wherever we see these legs, this is leg A and this is leg B, and then your hypotenuse is always c. Okay? So we have a squared plus b squared equals c squared. And this type of equation, since the variables, the highest degree on a variable is 2, which it's actually on all 3 of these. We call this a quadratic equation, and that basically just means that the highest polynomial of the second is of the second degree. So basically any of the variables, they're squared, and that's the highest exponent. Okay? So a and b are the legs, and c is the length of the hypotenuse. So one example that I could go through is if we have a right triangle whose legs have lengths of 3 centimeters and 4 centimeters, the hypotenuse will be 5 centimeters. And we can prove that by just plugging that into the formula. So we know that the legs are always a and b. So I can just do this, right? So we have this formula, just plug in 3 for a and 4 for b. Okay? So if I do that, I have 3 squared plus 4 squared equals, and I'm just going to leave c squared by itself. I'm just going to assume that I don't know the hypotenuse yet. Okay? So if I do 3 squared and 4 squared, I should get 9 plus 16, and that equals c squared. Well, and 9 plus 16 is just 25, right? So 25, and that's equal to c squared. Well, if I want to get c by itself, I could do that by square rooting both sides, right? Because a square root is the opposite of squaring something. So I should have 5 equals c. So the length of the hypotenuse c is just 5. Okay? And this is actually a special type of triangle that we'll talk about, or a special type of Pythagorean triangle. And that's just basically because the lengths of the legs and the length of the hypotenuse are all whole numbers. So in this case, we have a 3, 4, 5. Okay? And we'll talk about that in just a second as well. Okay. So let's go through a few more examples really quick. So this one says, at John's school, there's a regular patch of grass called a quad that measures 350 feet by 250 feet. John needs to walk from one corner to the other corner diagonally opposite of him. He could walk along a sidewalk that lines the perimeter of the quad, or he can cut across the quad in a straight line. He knows that the shortest distance between 2 points is a straight line, but what will that distance be, and how many feet will he save by cutting across? Okay, so we can find that out pretty easily, right? Because we know this is a right triangle right here. So we could find out how long it takes him to walk around the sidewalk here, and then we can just subtract that from the diagonal, or the distance that we cut across, to find out how many feet he will save by cutting across. So let's do that. So if I add these two together, so if he was going to walk the sidewalk, we would have, what? Let's see, 870 feet. So 870 feet is just walking the sidewalk. And then let's find the diagonal. Well, how can we find the diagonal? Well, I know it's a right triangle, and I know the length of my two legs. So what if I just square those, add them together, and then square root it to find out what d equals? Okay, so let's do that. That's just using the Pythagorean theorem. So we have 350 squared plus 520 squared equals, and in this case we have d for the hypotenuse, so d squared. Okay, so if I square both of those and I add them together, we should get 3,920, or yeah, 392,900, and that equals d squared. Right? So to get d by itself, we'll just do the inverse operation. So we'll just square both sides. So we get d equals about 626.82 feet. Okay. Now we know the length of diagonal, which is the first question, right? So what will the distance be of the shortest line? Well, that's just cutting across. And then how much feet will we save? Well, we'll just subtract these two, and we can find out how much feet we will save. So let's do that. So we have 870 minus 626.82. And if we subtract those, we get 243.18 feet. So we're saving about 243 feet by walking the diagonal versus walking along the sidewalk. All right, let's look at the next one. So it says to determine how much time he'll save by cutting across the quad, we need to know how fast he walks. So let's assume that he walks around 3 feet per second. Since the distance is rate times time, we can find the time by dividing the distance by the rate. Okay? Well, we already know how many feet he saves, right? We already know he saves about 243.18 feet. So if that's how much feet he saves by walking the diagonal, we could just divide that by his rate down here, feet per second, to just find out how many seconds he actually saves. So I do 243.18 and divide that by 3 feet a second, and we should get about 81 seconds. That's how much time he saved. Okay? And that's rounded just a little bit. So that's just how much feet he saved divided by his rate. If we divide those two, we get about 81 seconds. So he saves 81 seconds walking that diagonal rather than walking around the sidewalk. Alright, so let's try some more straightforward examples rather than like some word problems. So this one says find the length of a hypotenuse of a right triangle if the legs both measure 10 feet. So this is going to be a triangle, and I'm going to draw this out, where both the legs are 10 feet, right? And we don't know the length of the hypotenuse. So I'm just going to let that label be C for the hypotenuse. Okay? So I know from the Pythagorean theorem, since this is a right triangle, we can just do 10 squared plus 10 squared equals C squared, right? Because those are the lengths, the squares of our two legs, and that equals the length of the hypotenuse squared. Okay? So 10 squared plus 10 squared equals C squared. Right? So if I square those both, add them together, I should get 200 equals C squared. And if I square root both sides to get rid of that square, I have C equals, and it should be about 14.14 feet. So the length of my hypotenuse is about 14.14 feet. Okay. So what about the next one? The next one says find the lengths of the legs of a right triangle if the legs are the same length and the hypotenuse measures 10 feet. So we're kind of looking at it backwards now. So instead of both of these being 10, the hypotenuse is 10, and we have to find the length of these two legs. Okay? So let's do that. Let's just draw out our picture again. This is a right triangle. I know that my hypotenuse is 10 feet, but I don't know what the lengths of my legs are, right? So it's going to be kind of hard to find the length of both of them if we don't know some kind of relation, right? But we do. We know that they're both the same length. So if my first leg, I'm going to say it's A, is length A, well then I know the length of my other side is also length A because they're the same length, right? So if I wanted to plug this in the formula now for the Pythagorean theorem, I have A squared plus another A squared equals 10 squared, right? Well, what's A squared plus A squared? Well, that's just 2A squared because we have two of them. And that equals 10 squared is 100. Right? And now we can start solving for A. So what we can do first is divide by 2 on both sides. So we'll have A squared equals 50. And then after we divide by 2 on both sides, now we can just square root both sides to get A by itself. Right? So we'll have A equals the square root of 50. And what is the square root of 50? Well, if you plug that into your calculator, you should get it about 7.07 feet. Alright, so I'm kind of getting back to the first example when I started talking about the Pythagorean theorem, where we had this special triangle where all the sides were whole numbers. So we had a 3, 4, 5 triangle, and we kind of already proved that on the example, right? Where if we have two legs that are 3 and 4, if we square both of those, add it together, and then square root it, we should get the hypotenuses of length 5. Okay? So I want to show a few more examples of these Pythagorean triples. So I know this first one is a 3, 4, 5 triangle, just from the example up there and what we've done before. And then if I look at the next one down, so I have 6, 8, something else. Well, I know that if I look at this first one that we know and kind of look at the next one, I see that all we're doing is multiplying each leg by 2, right? So it goes from 3 multiplied by 2 is to 6, 4 multiplied by 2 is to 8, and then 5 multiplied by 2 should be 10. So we're just scaling everything up by 2, right? And then if we look at the next one, we're just scaling everything up by 3, right? So 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. Okay? And then the next one, it looks like we're scaling up again, but we're multiplying it by 10 this time. So we should have 30, 40, and 50. Okay? And the next one, I don't think there's any way to scale 3 up to 57 that I know of, so I know this is going to be a different type of Pythagorean triple. It's going to be kind of like a unique one. So I am going to work this one out. Okay, so I know that I have my two lengths of my legs, so I'm going to draw another diagram over here. And this bottom one is a little bit longer than this one, because I know that 76 should be longer than 57. Okay, so I have 57 for one length and 76 for the other one, and then I don't know what my hypotenuse is, so I'm going to label that C again. Okay, and then to solve for this, I can just use the Pythagorean theorem, right, because I know that it's a right angle. So let's do that. So I have 57 squared plus 76 squared equals C squared. Okay? So if I square both of those and I add them together, I should get 9,025, and that equals C squared. Okay? And now that I have that, to get C by itself, I can just square root both sides. So C equals, and you should get 95 in your calculator if you square root that. So I know that the length of this hypotenuse is 95, and that's just the blank that we're looking for up here. Okay, so I have 95. Okay. All right, and then the very last one, I can see that this is just scaled up from this fourth one that we did. We're just multiplying everything by 2. So if it goes from 30 multiplied by 2 is 60, 40 multiplied by 2 is 80, 50 multiplied by 2 is 100. Okay. And that should take care of that page. So let's move on to the next one. Okay, so I think this is the last problem here. So the last problem says a home builder is trying to square out the corners of a property. It says the string is secured 7 inches out from the corner on one side and 2 feet out from the corner on the other side as shown in the diagram. Right, so we have 7 inches over here, we have 2 feet over here, and then we have 25 inches for the diagonal. Okay. It says one side is angled out until the 2 marks are exactly 25 inches apart, and then a stake is planted at the property corner and each mark. So why do these measurements guarantee a square corner? What are some other measurements that the builder could use that might be more convenient? So if I look at this this picture here, this diagram that I'm given, I have this is in inches, this is in inches, but this one's in feet up here. So if I wanted to change 2 feet into inches, I know that my conversion factor, I have 12 inches and 1 foot. So if I have 2 feet, I'm going to have 24 inches. Okay? So now that everything's in inches, it might be a little bit easier to be able to use the Pythagorean theorem, right? So the Pythagorean theorem, I know that it always has to have a right triangle. So if this thing over here is a right triangle, because I know this is going to be across from the longest side, which is the hypotenuse. If this is equal, if this is a true statement, then I know this has to be a right corner, or right triangle. So it has to have a square, right? All right, so let's try to do this and make sure that 7 squared plus 24 squared is equal to 25 squared. Okay, so 7 squared plus 24 squared equals 25 squared. Okay, so let's just solve that out. Well, 7 squared I know is 49. 24 squared is 576. And then finally 25 squared is 625. Okay. So if I add these two together, I get 625, and that's equal to 625. Well, 625 is always equal to 625, right? So that's a true statement. So since I know that's a true statement, that means that this corner has to be square up here. So I know that that is this measurement that we just took, this Pythagorean theorem, this guarantees a square corner, right? And this is a special type of Pythagorean, or a special type of triangle. Not only is it a right triangle, but we also know that it's a Pythagorean triple, right? Because we have 3 whole numbers. So we have 7, 24, and 25. And those equal, in the Pythagorean theorem, we have 3 whole numbers, right? So if I wanted to write down another Pythagorean triple that I could give an example of, we have 7, 24, and 25. And that is guaranteed to be a Pythagorean triple, since they're all whole numbers and they do make that right angle. Alright, so that's my lesson for today. If you do have any questions or anything, feel free to reach out to me by email. Your homework should be due on Friday, next Friday, by the way. So you have 1 week from the day that I'm recording this to do it. Okay, I should have the other lectures up sometime in the next few days.